Welcome to True Projects. In this video, we are going to explain about the project that is privacy preserving keyword search with access control for secret sharing based data outsourcing. So before getting into the execution, first let us understand what is this project about. So basically the point here is that cloud computing is really popular because it lets people store and share a huge amount of data easily. Since the cloud isn't always fully trustworthy, people usually encrypt their files before uploading them, just to make sure no one else can read the content. Now, the problem starts after encryption. Once the data is logged with encryption, you can't just use normal keyword searches anymore. For example, if you uploaded any encrypted set of documents and then wanted to quickly find all the files related to invoice or project report, you wouldn't be able to do that directly because the cloud server only sees the encrypted content. So this creates a trade-off. On one hand, encryption protects your privacy and keeps the data secure. On the other hand, it makes the data less usable because searching inside encrypted files isn't straightforward. That's why researchers are working on techniques like searchable encryption so that users don't have to sacrifice usability just to keep their data safe. And when people store their data on third party cloud servers, they are basically trusting someone else to hold their information. But this comes with a set of risks. For example, someone without permission might try to access the data, or sensitive information could accidentally leak out. Another issue is that original data owner often loses control over who gets to search through the files or download them once they are in the cloud. Now, there are methods called searchable encryption that try to solve this problem by allowing searches on encrypted data. But many of these methods have their own drawbacks. Some are too slow or heavy to work well when you are dealing with large amount of data, and others don't have strong rules for controlling access because of these issues. They are not very practical for real world large scale that could use. So the main challenge here is figuring out a way to let people search through their data in the cloud without giving up privacy. The system needs to be secure, meaning that unauthorized users or the cloud provider itself shouldn't be able to see the contents of the file. At the same time, it has to be efficient so searches don't take forever, especially when dealing with a large amount of data. And another important part is access control. Only the users who have permission should be able to search and access specific files. In this way, sensitive information stays protected and users can still get the information that they need quickly without exposing anything to the cloud server. Essentially, the goal here is to balance security, privacy, and usability in the cloud environment. So, the proposed system is designed to make searching over encrypted cloud data both secure and also efficient. Traditional searchable encryption methods tend to be slow and don't provide strong access control, which can leave data vulnerable. This system solves that by using Shamir secret sharing, which ensures that only authorized users and legitimate cloud servers, those who hold valid secret shares, can reconstruct the original secret and perform keyword searches. Anyone without the right credentials is blocked, keeping the data completely private. And here, the secret sharing works by splitting a secret into multiple pieces, that is called shares. The original data can only be reconstructed when a certain number of shares are combined, so even if some servers are compromised, the data stays safe. And then comes access control. So the system also uses access control for each file. Public files can be searched by multiple users, but private files are only accessible by the owners. This ensures that sensitive information is not exposed to unauthorized users. And here, for actual search process, the system uses TF-IDF, that is term frequency inverse document frequency. It's a method that converts text into numerical vectors so that similarity between a keyword and the content of files can be measured. Using a cosine similarity, the system finds the most relevant encrypted files without ever revealing their content to the cloud server. Finally, there are two methods for handling secret shares, method 1 and method 2. Method 1 uses a general threshold, that is k, comma n, for authentication, while method 2 fixes the threshold as n is equal to k, which reduces computation time. So by combining secret sharing, controlled access, and intelligent indexing, the system makes sure that only genuine users can search encrypted data efficiently while keeping it secure and private. And enhancing the project, the system adds machine learning using logistic regression as an extension to handle keyword search operations. This means that searches aren't just done in a basic way. The system can analyze queries more intelligently, making search results faster and more accurate. On top of that, this approach helps the system spot unusual or potentially malicious activity while users are performing searches, adding an extra layer of security. And another improvement in the system is the use of Simon Spec cipher, which is a lightweight encryption algorithm. And unlike AES, which requires a lot of processing power, Simon Spec is much faster while still keeping the data secure. This means the data, that is encrypting and decrypting files in cloud, takes less time, resources, making the system more efficient without compromising the security. So these are the things that we have included in this project. Now moving on to the modules. So that is new user sign up. Here, this module allows both the data owners and data users to register with the cloud application so that they can access the system and its services. Then we have data owner login. So data owners can log in to upload their encrypted files to the cloud. They can set access controls for each file as either public or private. Only files marked as public are searchable and accessible by multiple users. Data owners can also view and download their decrypted files whenever they need it. Then we have data user login. So registered data users can log in to perform operations on the cloud system, primarily focused on searching and accessing authorized files. Then we have keyword search. In this module, a user enters keywords to search the files. The system verifies the user and the server by computing secret shares. Once the shares are validated, the system performs a search on the encrypted data using TF-IDF, that is term frequency inverse document frequency. And all files matching the search keywords are displayed, but those only marked as public can be accessed. Then we have quick time graph. So this feature plots the search time against different secret share parameters, that is N and K, to analyze the system performance. Then we have extension ML graph. So this extension ML graph, it compares the search operation time between the proposed method and the machine learning enhanced approach. Then we have extension to light encryption graph. So this graph compares the time taken for encryption using the original symmetric method versus the more efficient Simon Spec cipher, highlighting the performance improvement. So these are the modules. So to implement this project, basically we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requirements are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is all about the overview of the project. Now let's execute. To execute, let's open the code folder that contains source code files. These are the source code files of this project. In this, we have the dataset, and here is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have the database file. This is the Windows batch file. So instead of executing project through command line interface, we have created this Windows batch file. And here we have two sample files that we will be using in the front end. And here we have Shamir secrets Python code file in which we will be writing code related to the Shamir secret. And here we have spec related code in it. Now let's execute. To execute, double click on this run.bat file. Click on run. So here you can observe app.py file has been compiled by using this command. So this command is used to execute Python script and perform a runtime check for any syntax errors or logical issues. And after running app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I've copied it. I prefer Google Chrome, so I will paste it in that. So paste the link here and now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So this is the web page of the project. Now, before logging in as data owner or data user, we are supposed to sign up first. So click on new user sign up here and give the details to create an account. So let's create an account. First, let's create user. So let's give user as Kiran and give his password, give his mail address, give the contact number. I'm just giving a random number. Then give the location and select the user type. So let's select him as data owner. Now click on create account. So here, sign up process is completed. You can observe this message. Now let's sign up as data user. So let him be Karthik and then give his password, give the mail address, and give the contact number. I'm just giving a random number. So give the location also and select user type as data user and click on create account. So sign up process is completed. Now we need to log in as either data user or data owner. First, let's log in as data owner, Kiran, and then upload the file. So click on data owner login, give his password. So we have given it as Kiran password and click on login. We have logged in successfully. That is user Kiran has logged in successfully. And here you can see multiple options, right? So here, if you click on outsource data, you will be redirected here. Or if you click on here, you will be redirected here. So first let's upload the file. So click on choose file. So click on choose file, select sample one, click on open and now click on private or public. So let's give private for this. So click on private and click on upload data. So here if you observe, here we have uploaded successfully and this is the generated end shares. And here it is giving the information that file successfully shared with end servers with the above secret share. Now close this and let's open sample one for searching purpose. So let's open and keep this beside and get back to the application. Now click on choose file to upload it as public. Now let's upload the sample2 as public. So select it, click on open and select public. Now click on upload data. So here if you observe, sample2 has also been successfully uploaded. And here we have generated n shares and with the message that it is successfully uploaded with n servers with above secret share. So this is the secret share for the sample2 file. Now let's open that sample2 also and keep it aside. So this is a sample2 and this is sample1. So if we search keywords with these, I mean, if the data user, if we search keywords with the sample2, as we have given access as public, he will be able to retrieve this file. But if we search keywords with this sample one file, he will be not able to because we have given access as private. So he will be not able to, but this user, he will be able to download it. Now click on this, click on close. Now click on view and download data. Here, if you observe, user Kiran has uploaded two files. As he is the owner of the file, he will be able to download both of them. So let's click on download here, click on download, click to download. Here, if you observe, sample2 has been downloaded. Now let's log out. Or else I'll be showing you how the private will also be downloaded. So let's log in again. Click on view and download. And let's download this private file. As his owner, he will be able to download the file without any permission. So you can observe he has downloaded. Now log out. Now let's log in as data user. So give the password and the username. So the password and the username is Karthik. I've entered username and the password of data user. Click on login. So we have logged in successfully as a data user. Here he has to search for the keywords. If we click on this, he will be redirected to this page, or if we click on this keyword search, he will be redirected to this page. Now let's start doing searching. For that, let's open sample 2 and let's copy the first sentence, copy it, get back and paste the search. Click on search files. So here we got the maths course. So this is the file name in which that sentences are there, and here is the search score. And here if we click to download, we will be able to download the file. Click on click to download. So here you can observe sample 2 has been downloaded. It is in this file, that is why it is showing the highest search score, that is 0.28. For all the rest files, it is showing 0.022, which is very minute score. Now let's get back and search with the sample 1 text. So let's open the sample 1 and select it, get back to the application and paste it. Click on search files. So here if you observe, no matching files found with the keyword secure resource management SRM with the cloud. As we have given it as private, that is private access, this data user Karthik is not able to download the file. Now let's check with the extension. Before that, let's check with the query time graph. So click on it. So here we have the query time analysis graph, which is the performance comparison between proposed method and the proposed method 2, that is proposed method 1 and proposed method 2. Here on x-axis, we have algorithm iterations, that is it represents k value, and y-axis it represents search time. And here blue color, it represents proposed method 1 and pink color represents proposed method 2. In both the methods, that is method 1 search time and pink line represents method 2 search time. In both the methods, method 2 is faster one. So that is why we have in the down, that is which is below the proposed method 1. It shows the very less computation time. Now let's check with the extension ML graph. Click on that. Here we have the graph. This is the machine learning performance comparison between proposed search time and the extension ML search time. Here on x-axis we have proposed search time and extension ML search time, and on y-axis we have search time, that is in seconds. Here if we look at it, the extension ML search time is taking very less search time than the proposed search time. Now let's see light encryption graph. So click on that. So here we have encryption analysis, which shows the performance comparison between proposed symmetric encryption and extension spec cipher time. Here on x-axis we have the encryption technique, and on y-axis we have encryption time in seconds. Here if you observe, extension model is taking less encryption time. Now click on logout. So this project's proposed system provides a secure, efficient, and privacy-preserving framework for performing keyword searches on encrypted cloud data. So by integrating secret sharing, access control, and intelligent search mechanisms, it ensures that only authorized users and genuine servers can access it and retrieve the information. So the system effectively balances data confidentiality, usability, and performance, making it suitable for secure and practical cloud storage and retrieval applications. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.